Hello again. This is Math 1115, remote delivery for April 20th, 2020. This is part 2 of 2 parts for today. The content covered is from section 6.5, and I encourage you to use buttons like this on YouTube throughout to perfect. Some opening comments. The pipe fitting project is due on Wednesday. That's the next class meeting that we will have, the next remote delivery. Points are involved. And again, self-grading and self-reporting will be the protocol. We're rapidly finishing Chapter 6, and there will be a quiz over Chapters 5 and 6 together upcoming. In preparation for the protocol for the final exam, the online assessment will happen, and so that will be different. It will not be self-graded and not self-reported. More about that later and soon. And finally, on this slide, our last project will be due on Wednesday. So the finish line is in sight. I encourage you, if your circumstances at all permit, do not quit now. Finish strong. Your educational goals need not be deferred. Today's topic is multiplying and dividing fractions. Since we don't use a graphing calculator, we're not going to talk about using a graphing calculator for checking your answers, because that's outside of the scope that we've defined for the course. Okay, so let's review how we multiply and divide fractions. If you have a fraction a over b times a fraction c over d, you multiply across the top, the numerator times the numerator, and the denominator times the denominator. Sometimes this is something that would have to be reduced further to put it in lowest terms. You also remember that if you divide fractions, so I'm taking the fraction a over b, dividing it by the fraction c over d. By the way, that's the same thing as having a over b in the numerator and c over d in the denominator. The two steps involved in computing this are: you invert the divisor. That means you turn it upside down. So instead of c over d, it is d over c, and you multiply. And now we use the rule for multiplication across the top and across the bottom. So we invert and then we multiply. Let's look at some examples. Here we have 3 over 5 times 2 over 7. Multiply across the top, 6, across the bottom to get 35. No common factors, so we're done. Here we have some variables involved. We have 3a over 5b, 15b squared over a. So you multiply across the top and across the bottom, but now we're going to put it in lowest terms. So 5 goes into 5 once, 5 goes into 45 9 times. A cancels with the a, and b goes into b squared 1b times. So the answer is 9b. Here's another example. And sometimes it's useful for students to think of 6x as being 6x over 1. And that's what's portrayed here. Now this is a multiplication problem, so we multiply across the top and across the bottom. We get this as our preliminary answer, but we want to put this in lowest terms. So 3 goes into 3 once, 3 goes into 12 4 times. The x squared and the x up here will have a net of x in the denominator, and y is by itself. So the final answer here is 4y over x. Here's another more complicated example with algebra, and the suggestion is that we first indicate the multiplications. So what happens is, since this is a multiplication, we take the top times the top and the bottom times the bottom, and we just write it this way. But now we need to reduce this, so we're going to factor everywhere that we can factor. So in the numerator, you realize that we can factor x squared minus y squared as x plus y times x minus y, and now we're going to cancel common factors. Well, the 3's will cancel, and the x minus y squareds will cancel. The reason we have x minus y squared is here is x minus y times itself, and here is x minus y times itself again. So that gives us x minus y squared, so all of those cancel, and you get x plus y over 2x plus 3y. Let's look at another example of multiplying algebraic expressions. So this times this, this times this. We multiply first, but now we start looking for common factors, and notice that we factor 2x squared plus x minus 15 into this expression, because we factor completely to see what common factors might cancel. Now we see that this 2 goes into 2 once, 2 goes into 4 twice, so we have a 2 down here. And we see this x plus 3 will cancel with that x plus 3. So the final answer is x minus 2 times 2x minus 5 divided by 2 times the whole of 3x minus 1. Now we're going to look at some divisions. So here we have this fraction divided by this fraction. Again, there's 2 steps. You invert, so you change the 5 over 3 to 3 over 5, and then you multiply across the top and the bottom. We get 18x over 35. There are no common factors. We are done. Here we have a numerator divided by a denominator. So what we do is we invert the denominator. So instead of 2c squared over a, we write a over 2c squared, and we multiply. Now we multiply across the top and across the bottom. We get 3a cubed over 10c cubed. No common factors. These things do come up in physics applications, and finding the center of gravity is discussed here, but it's really just a formula. They don't derive it. And so this is the expression that you get. It actually is a division problem. So what you have to do is you have to take this fraction divided by this fraction, but this is in parentheses, so you're going to multiply through here first, because that's the order of operations. Let's see what we get. So this divided by this, first we multiply in here, and you see the 2's will cancel. I'll get pi squared, pi times pi, and I will get r squared because of that r squared. So when we multiply across the top and across the bottom, we get this. The 2's are going to cancel. This 2 will cancel with this 2, and so we have this division. And now we're going to invert the divisor. And we invert the divisor and get 1 over pi squared r squared. Then we multiply. And now what we're going to do is multiply across the top and across the bottom. We'll get this, and now we'll simplify this. R cubed over r squared is a net of r in the numerator, and pi over pi squared is a net of pi in the denominator. So this is the exact answer, and they do talk about approximations here, but we're after the exact answer. Let's look at this example. We have this expression divided by this expression. Again, it is useful for some students to change the first one to have a division of 1, and we're going to invert. That means we turn this one upside down. So instead of 2x plus 2y over 6x plus 15y, it's the reciprocal of that. And now we multiply. Now we factor everything. We can factor a 3 out of the second term. We get 3 times 2x plus 5y. And down here we can factor a 2 out of that. So now we're going to cancel common factors. We see there's a common factor of x plus y. We cancel that, and so this is our simplified answer. Here's another example of dividing algebraic expressions. It's this complicated expression divided by this complicated expression. Now there's a lot of factoring going on, but here are the 2 steps. We invert the divisor, so instead of this, we write it this way, and instead of dividing, we are multiplying. Now we factor everything. So here we're factoring the difference of perfect squares. Here we're factoring the difference of perfect squares. Here we're factoring this trinomial this way, and we're multiplying by that. And now we're going to cancel out common factors. Notice that up here I have 2 minus x, but here I have x minus 2. So those are going to cancel, but that's going to give a negative like we discussed in the last section. And the x plus 2 is also going to cancel with the x plus 2. So now what we have is this expression remaining. And this or happens because you can put that minus in the denominator to change to that if you choose. They're both equally good answers and both equally correct. Now before embracing homework, I'm going to encourage you to try a couple of practice exercises here. John's been very gracious giving you homework to do, and I encourage you to do it. But let's test your understanding first on this. So hit pause. Let's see how you did. Let's see how you did. Those are the answers that you should have gotten. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And take care of yourself and of others. See you in